Alrighty, so let's go ahead and do problem number 3. It says after the bumper cars hit, oh no, they fall into this pillow, and we wanted to talk about what the pillow's purpose is. A lot of you wrote that the pillow cushions the fall. I know that it cushions the fall, but you need to talk about why cushioning actually matters in terms of impulse and momentum. So specifically what we have is, we have that Ft equals mv final minus mv initial. Now here's the thing, whether you have concrete or a pillow, this is the same. This is the same for pillow or cement. And of course we don't want a kid falling on cement. So here's actually what happens. What happens is the pillow increases time and the force actually decreases. And what actually means here, what this actually means is the impulse is the same. And what happens is we reduce force by increasing the time. And that's the key. That's the key to doing this problem. Alright, so now we're going to do problem number 4. Let's start with the free body diagram. So we're going to have this little, whatchamathingy. Well, we're going to have the normal force in the chair. That's great. And we're going to have the weight force of young Kurt. Let's actually figure this out. So he drops 10 meters in 6 seconds. So let's get his acceleration to start with. So that's going to be, let's use our kinematics formulas. X equals 1/2 at squared. Ooh, sorry for that writing. Plus v naught t plus x naught. When we plug in everything, we're actually going to get that 10 equals 1/2 times a times 1.6 squared. So we're actually going to need to go ahead and solve for a. When we do that, we're going to get, so we're going to actually end up getting an acceleration. Sorry, I had to pause the recording to get the value. The acceleration is going to be 7.81 meters per second squared. And that's downward, so it's actually going to be negative. So let's go ahead and, again, the negative is because it's downward. Now let's set up our unbalanced force equation. We're going to have the normal minus gravity makes the mass accelerate. And so we're going to end up getting that the normal force on Kurt minus his 20 kilograms times 10, because gravity, g is 10. Remember, Fg is mg. Don't forget that part. And that's going to equal 20 times negative 7.81. So when we actually solve for the normal force, we're going to get a little bit of a smaller number. The normal force is going to end up being, let me just calculate this, so 200 minus 20 times 7.8 is going to give us about 43.8 newtons. And that's the answer to number 4.